assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So here we're going to be calculating what the wavelength is when we are given different energies. So the equation we might normally see is that the energy is equal to hc over the wavelength, where h and c are both constants. But if we rearrange that to solve for wavelength, that would be equal to just hc over the energy. So starting with part A, we are given an energy of 142 kilojoules per mole. So the wavelength will be equal to H, which is 6.626 times 10 to the negative 34th. C is our constant of 3 times 10 to the 8th. And then we put our energy on the bottom. However, it's a given in kilojoules per mole, and we want it in just joules. So first thing we have to do is multiply it by 1,000 to get it in terms of joules. And then we're also going to add up here the Avogadro's number to put it, get rid of that moles so that it is just in joules. And then when you multiply all of that out, you get a wavelength of 8.43 times 10 to the negative 7th, and that is in meters. All right, for part B, it is the same thing, but we are just going to change what that energy is. So we have 6.626 times 10 to the negative 34th times 3 times 10 to the 8th, all of that over 45.5, and that's going ahead and multiplying by 1,000, and then we just have to multiply it by Avogadro's number. Sorry, that was supposed to say 10 to the 23rd. Messed up there. And then when you multiply all of that out, we get an answer of 0.00263 meters. And then the last part, which is part C, same setup, just a different energy. So 6.626 times 10 to the negative 34th times 3 times 10 to the 8th, all over 4.81. We can just do it times 10 to the 7th. That puts it in terms of joules. And then we also still have to multiply by 6.022 times 10 to the 23rd. And when we multiply it all out, we get an answer of 2.49 times 10 to the negative 9th meters.